Well, I'm early.
Huh?
And I'm early.
No, you're on time, girl. Everybody else is late.
Period.
Alrighty. So, how many people are using their Chromebook for the chat? Okay. If anybody is not using their Chromebook, what I'm doing is, like, I tried this out yesterday. I'm actually doing this at the same time. So I am streaming my, I'm doing the Google Meet right now, but I'm also live streaming on YouTube Live. And what's kind of nice about that is the video quality through Google Meet is trash, but if you watch it on YouTube Live, it's a lot higher quality and it's much clearer. Unfortunately, you guys don't have access on your Chromebooks because it's blocked. But what I'll do is I'm going to share the link in the chat so you guys have access to it if you wanted to like watch it on your phone, or if you guys have like an iPad or something or your own computer, you can watch it on that. Okay. Yeah, make sure you like and subscribe and hit the bell icon for notifications. Alright, let me go ahead and start taking attendance. Alright, so Alvaro's here. Alfonso is not yet. Andrew is not. Anthony, nope. Brittany, nope. Cameron's here. Caesar's not. Jamar, nope. Denasia, good. Damara, nope. Destiny's good. Elijah, Kaylee, it's not. Kimberly, there's Jamar. Kimberly's here. Monte, this is not here. Myra, good. Michael, yeah, I got you, Jamar. Michael's not here. Alright, I got you, Alfonso. Alright. Michael, Miguel's here. This is here. Naheem, Sayas. Alright. Ranchana, right here. Sean's here. Shanice is here. Trinity is not here. Alright, Michael, nope. Kaylee, nope. Damara, nope. Caesar, nope. Brittany is here. Andrew and Anthony. Okay. All right. So, let me go back in the chat. All right. So, if anybody is using a device that's not their Chromebook, this is a link to the YouTube Live that I'm doing right now. So you guys can watch it on that versus watching it on the Google Meet. It's gonna be a lot clearer and a lot sharper. So I tested that out yesterday, and what's really nice is that it records it as I'm doing this. So I'd rather you stay in the chat. So like if you have questions or something, or if I call on you, you can still respond. Does that sound cool with you, Sean? Okay. And what's also kind of nice is like when you guys unmute and talk to me, like it gets pulled up into the YouTube Live also. So it's not like you guys are responding. Like if I'm responding to somebody in the chat, like the text chat, it's a little weird because you can't see the chat on the YouTube Live. But if you guys unmute and talk to me, then you can hear the conversation. All right. So on that note, I did post something on Canvas. I'm hoping the audio is fine here. Okay. So on Canvas, I made an announcement, and this is going to be the study guide for our first assessment. Okay. Our first actual assessment. So the link to the assessment is here. Like I hyperlinked it. And then any supplemental material that, that you need to like have for review or extra practice, I've got those linked right here. Okay. So what I want to do today is to go through the assessment study guide. Okay. The study guide is not for a grade, so you don't have to worry about that. There is a due date, but as long as you go through it at least once or twice to make sure that you understand how to do it, you're going to be fine. So everything that's on the study guide is fair game for the assessment. The material that's on the assessment, all the material that's on there is going to be from the study guide. There's not going to be anything that's on the assessment but not on the study guide. Does that make sense? So if you understand how to do everything on the study guide, you should be good to go on the assessment. Any questions about that? I try to make it as straightforward as possible. So I'm going to jump over here to y'all's class. Add another page. Get rid of that. Okay. All right. Is everybody good? Any questions? Ready to rock and roll? Yeah, Mr. Applewhite. Oh, there's Trinity.
Hi, Mr. Applewhite.
Hi, Trinity. All right. So last call for attendance. Andrew, Anthony, Caesar, Damara, Kaylee, Michael, Ranchana, and Panisha? Okay. Alright. Here we go. So in order for this to go smoothly, and for me to be able to go through this so it's not like me waiting for an answer, if you guys can, when I ask a question, if you all can unmute and respond verbally, that'll just make this go a lot smoother. Cool? Is that cool?
It's cool.
There we go. All right. So, this is a velocity versus time graph, okay? And I kind of cleaned it up a little bit, and I made the color of the shaded area kind of pop out a little bit. So I'm hoping that by having the different color, it kind of helps you guys out. All right. So when it comes to position on these velocity versus time graphs, the position, like whether I'm moving forward or backwards or in the positive or negative direction, depends on where the shaded region of the graph is with respect to the horizontal axis. So from the first, second, and third time intervals, what's up, Trinity? No, it does not. This is not an SOL course. I would not teach an SOL course. But even if there was, you guys would all pass. Because I'm so good at what I do. All right. Here we go. So, if my shaded region is above the x-axis, then that means that I'm moving in the positive direction. If it's below the x-axis, then I'm moving in the negative direction. So what this chart is asking is, what is my position doing from time 0 to time 1? Time 0 to time 1, I am above the x-axis, so therefore I'm moving in the positive direction. Same thing goes for 1 to 2 and 2 to 3. So these are going to be positive. Cool. And real quick, I'm going to put the link in the chat one more time. Oh, come on. Copy it. So if you're on something other than a Chromebook, you should be able to access this link and watch it on YouTube Live versus on Google Meet.
Applewhite.
What's up?
So as you're doing this, like, do we do the study guide too with you?
You can, or you can just pay attention. It might make sense to, if you're pretty confident with the material, what I would do is I would just watch me and interact, and then do it on your own afterwards. If you're not so sure, I would kind of follow along, but I don't want you guys to kind of get lost in doing it yourselves and not understand or not hear what I'm talking about and explaining in the chat. That makes sense? But I mean, you're more than welcome to if you want to. Cool. And again, the study guide is not for a grade. Even though there's points on it, like this one says 22 points, it's not graded. Okay, so don't worry about that. I want you guys to actually understand what's going on. I don't want you to worry about getting a grade for it. Cool? Alright, so for the first 3 time intervals, from 0 to 1, 1 to 2, 2 to 3, these are all above the x-axis. So I'm moving in the positive direction in that time interval, from 1 to 3. From 3 to 5, however, they're below the horizontal axis, so therefore I'm moving in the negative direction. So I'm going to select negative for these 2 options. So any question about the position? If nobody responds, I'm going to assume that we're all good.
We good.
All right, thank you. Liking that feedback. All right. When it comes to velocity, I look at my time interval. So this is 0 to 1. So I look at the vertical line from my left bound, the vertical line from my right bound, and I look where my function, and my function line should be a different color. I apologize about that. I look at where my function intersects this line and this line, and I figure out what the y value is. So the y value, when my function hits this line, my 0 second line, I'm at 0 meters per second. At 1 second, I'm now at 90 meters per second. So if I go from 0 to 90, my velocity is increasing in value. From 1 to 2, I start at 90 and I remain that until 2. So in that situation, my velocity remains constant. From 2 to 3, I go from a positive 90 down to 0. So 2 to 3, I am decreasing. From 3 to 4, I go from 0 down to negative 90. So the y value is negative 90 down here. So I'm still decreasing. And then finally from 4 to 5, I go from negative 90 up to 0. So in that situation, I am increasing. So increasing, constant, decreasing, decreasing, increasing. Cool? All right. Now for acceleration. Acceleration, I look at what my slope is. Is it positive? Is it negative? Or is it 0? So from time 0 to time 1, I have a positive slope. 1 to 2, there is no rise, or it's not going up or down. So that means my slope is 0. 2 to 3 is negative slope. 3 to 4, negative slope. 4 to 5, positive slope. So negative, whoops, negative, and lastly, positive. Any questions about that?
No.
All right. Now, since we've gone through a bunch of these problems, and you guys kind of understand the mechanics of how to get the answers, I kind of want to finally polish the concept of what on earth finding the area is. So, when we're trying to find the area that's in between our velocity function and the horizontal axis, if it's a velocity versus time graph, this shaded region is telling us how our position is changing. So whatever that value of area is, that's how much my position is changing. Okay? So in this case, the area is going to be, because this is a triangle, the area of a triangle is 1/2 times the base times the height. All right. There's Sean. So in this case, the base, so my horizontal axis is seconds, and from 0 to 1 second, the base of my triangle is 1 second. The height of my triangle, right here, is 90 meters per second. So it's 90 meters per second for the height and 1 second for the base. So I take the magnitude of the base, so it's 1, and multiply by 90, I get 90. And the meters per second times the second, I just get meters. And then because it's a triangle, it's 1/2 times the base times the height. Do I need to be writing this down? Or are you guys tracking?
We're tracking.
Okay.
Well, I'm tracking.
Okay. So the quick little trick that I've given you guys is if my base is 1 second, all you have to do for a triangle is I look at the height of the triangle. In this case, it's 90 meters per second. And I just divide it by 2 because of the 1/2 base times the height. The base is just going to be 1. Wherever the value of the height is, I just take that and I divide it by the 1/2. Or divide it by 2. Multiply by 1/2. So if it's positive 90, if I divide that by 2, I get a positive 45. This is a rectangle. The area of a rectangle is just base times height. So in this situation, base of 1, height of 90. 90 times 1 is 90. I get a positive 90 there. This is the same height as this here. So this triangle has the same height as this. It also has the same value for the base. So this is also going to be a positive 45 meters. Cool. The height of both of these triangles here, they are both negative 90 for the height. They both have a base of 1, so they're going to have the same value. So I look at the height is negative 90. I divide it by 2 because these are both triangles. So I get negative 45 for the last two. Any questions about that? Alright. When it comes to my distance, I just care about the magnitudes. I don't care about the negative signs. So I'm going to add up all the magnitudes or all the values of what we found in the area part. So 45 plus 90 plus 45, that's going to be 180. And we don't include the negative signs. So we have 180 over here. This is another 90, so we end up getting 270. So we get a positive 270. Displacement, on the other hand, that one is a vector quantity. So we do have to include the direction, and how we're including the direction is the negative signs. So when we're doing the displacement, I have to include the negative signs, or in other words, I add up everything just like it is. So 45 plus 90 plus 45, that's 180. And then I add another negative 90, because negative 45 plus negative 45, it's a negative 90. So 180 minus 90, I get a positive 90 going forward. Cool?
Cool.
All right. I'm taking the silence as everybody's comprehending. All right. So, what velocity is the object moving in this graph? So, do you guys remember how to do velocity? How do we find the velocity? I'll give you guys a hint. Velocity is equal to distance over time. So, the amount of distance that I cover is 50 meters. The amount of time it takes is 25 seconds. So it's going to be 50 divided by 25, which is what, Miguel? Dos. Is it positive or negative? Good. Any questions about that?
How do you solve that again? Because
Oops,
I kind
sorry.
of forgot.
Yeah. So, velocity is equal to my change in position over my change in time. Cool? So, in this case, my change in position is just going to be my final position minus my initial position over the time it takes to do that. You track it so far? You tracking, Myra? Making sense?
Not really.
No? Okay. Okay. So, in order to figure out how fast I'm going, right? That's what the velocity is. It's how fast you're moving. The rate of your change in position, like how much you're changing your position in a certain amount of time. Was that Anthony? Anthony, you better start showing up on time. Alright, fix the attendance real quick. Alright. Sorry about that. So, let's do this. If I start here at 0 meters and I go to 100 meters, so this is where I start and this is where I end, and I do that in a time interval of we'll say 50 seconds. So it takes me 50 seconds to go 100 meters. Okay, so this is just a hypothetical situation. Are you tracking so far? If I go from... Okay. So I start at 0 meters, I go to 100 meters, and it takes me 50 seconds to do that. So what I'm going to do is I'm going to take my final position, which is 0, or is it 100?
100.
Good. So I'm going to put 100 right here. And then my initial position would, of course, be the 0. So I'm going to put the 0 here. And then the amount of time it took was 50 seconds. Cool with that? And we've got meters up here, and we have seconds down here. So, oh, that should be a minus sign, not a multiplication. So 100 minus 0 is 100. Divided by 50. And then I've got meters per second. And this reduces down to 2. Because 100 divided by 50 is 2. So I would be going 2 meters per second in this situation. That make sense?
Yeah.
Okay. Now, what if I did the same movement? I went from 0 to 100, but I didn't do it in 50 seconds. I did it in 25 seconds. Before we do any math, would you say that I went faster on the second time, slower, or the same speed?
If you went from 0 to 100, right?
Yeah, if I went from 0 to 100, but I did it in 25 seconds versus 50.
Would it be faster?
It would be much faster, yeah. It would be twice as fast. That make sense? Because I got there in half the time. So, in this situation, instead of 50 seconds, I'm going to switch this to 25. And if that's 25, that means that this is 25. So 100 divided by 25 is now 4 meters per second. So like I said just a second ago, I went twice as fast, and that is the case. I was going 4 meters per second versus the 2 in the previous. Make sense?
Yes.
Okay, cool. So, with that piece of knowledge, if we go back to our problem, we had 50 meters. So I started at 0, I ended at 50, and it took me 25 seconds to do that. So I ended, my final position was at 50. My initial position was at 0, and it took me 25 seconds to do that. So that's going to be 50 divided by 25. So that's going to be 2 meters per second. So that's how we got that. Oh, why didn't you tell me that my face was in the way? Okay. So, is that clearer now?
Yes.
Yes.
All right, cool. All right. So if we go to the next problem, this one is very similar, but it's a little different. So this is where using this formula really helps. Okay. So my initial position is here at 50 now. All right. Thanks, Caesar. All right. So my initial position is at 50. My final position is down here at 0. So my final position was at 0. My initial position was at 50. The time that it took to do that was 25 seconds. So now in this situation, 0 minus 50 is going to be a negative 50 over 25 meters per second. So then I get a negative 2 meters per second. Any questions so far? So negative 2 meters per second. So this question is using the same one that we did in this previous problem, the same graph that we just did, and it's asking choose the velocity versus time graph that corresponds to the motion. So in other words, which of the following graphs that I'm getting ready to show you, which one of those shows a velocity of negative 2 meters per second? So which number 1, 2, 3, 4, or 5, which one of those shows a negative 2 meters per second?
The fourth one?
Correct. So it is going to be graph 4. What's going on in 3 and 5? How would you explain what's going on?
Number 3, the negative 2 is just increasing to the 0. It's just increase.
Yeah. So my velocity is increasing to 0. So here's a kicker. What's physically happening in number 3? If I was in my car, how would you describe the motion of my vehicle to match graph number 3?
Reverse.
I would be going in reverse, but how would like at time 0, I'd be going 2 meters per second, right? In the backwards direction. And as time goes on, so over the time span of 25 seconds, my velocity is doing what? So I'm going backwards, I'm like, all right, cool, going like this, and am I hitting the gas or am I hitting the brake over that 25 seconds?
Brake.
The gas?
Ooh, gotcha. So, I'm actually hitting the brake even though my velocity is increasing because I have a very negative velocity going backwards. In order to stop going as fast backwards, I have to slow down, right? So I have to hit the brake, and then as I'm hitting the brake, my velocity is getting more and more positive. Make sense? Until I get to 0, where I stop, and then in order to continue to go and have a positive velocity change, I have to hit the gas at that point. So in this situation, I am slowing down, but I'm increasing velocity at the same time. Does that make sense? So I'm increasing my velocity, but I'm also slowing down at the same time in number 3. I think these ones are kind of cool. But I digress. The actual answer, so it's asking which of these velocity versus time graphs match with this. This was the graph in the last question. We figured out it was -2 meters per second. And this is the one, graph number 4, that shows -2 meters per second. Cool? All right. So let's kind of test your knowledge. So this is a position versus time graph. From 0 to 25 seconds, what's happening to my position?
Increasing.
I'm increasing my position in the positive direction. So if I'm increasing my position as time goes on, I have to have a velocity. Okay? So that means that in these graphs here, I have to have a value for my velocity. So it can't be on the horizontal axis. So that kicks out the first one, because that says from the first 25 seconds, I have 0 velocity. So that's not true. And it's also increasing my position. So I have to have a positive velocity. So that kicks this one out and kicks this one out, because these ones start off as a negative velocity. So we have 2, 3, and 4. Okay? Because they're
Isn't
all
it
positive values. It is, but let me get to it. So 2, 3, and 4. Oops. So graphs 2, 3, and 4 all have positive values. Now I'm not looking at the numbers yet. From 25 seconds to 50 seconds, my position doesn't change. So if my position doesn't change as time goes on, I'm stationary. If I'm stationary, I do not have a velocity, i.e. my velocity is 0. So I need to look for a graph that has a line for 0 in my velocity versus time graph from 25 seconds to 50 seconds. And it would be graph number 2. Does that make sense? That's it. Graph 2. All right. Okay, so there are going to be some unit conversion ones. I'm going to hold off on these for a second, and I'm going to switch to, I think it's Question 11. 12. Come on. 13. Here we go. So I'm going to come back to the unit conversion ones. Okay. Because the reason why is because the unit conversion ones are going to be different for each person. No. You're not taking the assessment today. It's going to be next class. No, that would just be cruel. I'm not that mean. You guys have been with me for almost 2 months now. You should know me better than that. Alright. So, this one should be pretty easy. Select all the following that are units of length. So, somebody unmute and tell me which ones are units of length.
Meters.
Alright, so meter.
Meters?
Kilometers.
Yep, kilometers.
Is it inches
Inch.
and feet?
Yep.
Kilograms?
Kilograms. So we're measuring length. And what is a kilogram measure?
Weight.
Mass.
Distant.
Gotcha. So kilograms measures how much mass something is. Okay. So we're going to get to that in a second. But when it comes to length, if you look at, I want to say, come on. I don't know why this takes so long. Okay, look at the announcement. And this one. So this is the PowerPoint that I gave you guys before. So here we go. So you got the metric system lengths here. You have the mass. You got time. And then that's conversions. Alright. So with mass, we're going to have gram, kilogram, and milligram. Okay? Let me go back to this. So kilogram, gram, those are units of mass. Seconds and hours, those are units of time. Cool? So if you think about, I thought I gave you guys a list of them last time. I might be wrong. I thought I showed you guys this. Didn't I show you guys this? No, I guess not. Alright. So, we've got inch, foot, miles, yards, millimeters, centimeters, meters, kilometers, and nanometers. So those are all different units of length. For time, minutes, seconds, hours, days, weeks, months, years, and so on. This is milliseconds, and that's nanoseconds. So when it comes to mass and weight, mass, we're going to have grams, kilograms, milligrams, and those are going to be in the metric system. The unit of mass in the imperial system is called a slug. All right? That's a nice little tidbit of information, but you're never going to use the unit of slugs. Whenever you hear ounces or pounds, that's going to refer to the weight. So weight is just the force of gravity pulling on a mass. Make sense? Mass is how much matter something has, and weight is the force of gravity or the acceleration due to gravity pulling on the, it's not the right terminology, but I'm just going to go with it. It's the effect of gravity on that mass. Okay, that's the weight. It's the force due to gravity. Does that make sense? Okay. So, are mass and weight considered to be the same thing? Remember what we just talked about.
False.
It is false. So mass and weight, in the colloquial sense, like in the normal day English or just normal day talk, they are used interchangeably. If I'm like, man, this has a lot of mass, or man, this weighs a lot, we mean the same thing when we're talking, but in the scientific field, mass has a different definition than weight. So they're not the same. Okay. Oh, and I forgot to change the thing before. Dang it. Alright. Let me get rid of my face. There we go. Alright, so Mr. Applewhite steps on a scale in the United States and got a value of 180 pounds. What would the scale read if I moved to the moon? Would it read higher than 180 pounds, lower than 180 pounds, or would it read the same?
Lower.
Lower than?
Good. So the unit of pounds is a weight. It's the force due to gravity pulling on me. Okay? That's what we use in the United States. We use weight, or the units of pounds, which is weight. Okay? Now with this one, I'm now in Great Britain, and this is where I made the mistake. This right here should be 82. That should be 82. So if I was on a scale in Great Britain and I got a value of 82 kilograms, what would the scale read on the moon? Kilograms is a measurement of what? Mass or weight?
Weight?
So kilograms is a measurement of mass. Cool? So the only times that we're going to be talking about weight, so if you see something, like if you see a unit that you're used to, like ounces or pounds or tons, that is weight. Anything else, all right, now take this with a grain of salt. Anything else, like anything that seems scientific, if that makes sense, that's going to be mass. Anything that you're familiar with, ounces and pounds, that's weight. That make sense? So, like I said, these 180s right here in the answers, those ones should be 82. These should both be 82. I need to go back and fix that. So, if I step on the scale and I get a value of 82 kilograms, that's telling me how much mass I have, how much matter I am. If I go to the moon, assuming that I'm not going to have my arm cut off or, like lose a hand, do I have the same amount of mass?
No.
So think about all the atoms that I'm made up of. And I'm on the Earth, right? And I step on the scale, and the 82 kilograms is referring to how much atoms I have, right? How many atoms I got. If I go to the moon, do I get more atoms or lose any atoms? Unless I cut my hand off?
No.
No.
Correct. So, assuming that, any atoms or any, skin cells that I lose, that's not going to make that big of a difference. If I had something and I if I had an object that was like pure something, whatever, a pure material, and I get it a certain amount, excuse me, a certain amount of kilograms on the Earth, and then I immediately teleport to the moon and I measure it then, the kilograms would be the same. The amount of mass or matter of that object does not change. It didn't get any more material, it didn't lose any material. So the measurement of the mass remains the same. Is everybody tracking with that? So this might make a little bit more sense. When it comes to so we represent mass with a lowercase m, and I'm going to put that in square brackets to represent that being a variable. The acceleration due to gravity, and this is going to be something that we're going to get into later. I'm just going to call it gravity for right now, is the lowercase g. And this thing here, the force due to gravity, so the amount of force that gravity is pulling on that object, this is what we consider, or this is what we call weight. Does it make a little bit more sense now? So mass is represented by a lowercase m, and weight is also called the force due to gravity. Okay, the force that gravity is pulling on an object. So anytime that you hear force due to gravity, or you hear weight, these things are the same thing. Force due to gravity and weight are considered to be the same thing. So, if I want to figure out what my weight is, or my force due to gravity, my force due to gravity is equal to my mass times the gravity. Does that make sense? So this is weight mass gravity. So weight and gravity, or weight and mass, are not the same. If I go to the moon, what happens to my gravity? Does it go up or down? Is there more gravity or less gravity on the moon?
Less gravity?
Correct. So gravity will go down, and if my mass stays the same and my gravity goes down, what happens to my weight in order to keep it equal? Am I losing you guys? Go ahead.
Does it go down?
Yes, it also goes down. Does that make sense? If I go from the moon to the Earth, my gravity goes up, so therefore my weight also goes up. So weight depends on gravity. If I don't have any gravity, so if gravity goes away, if I'm in the middle of space, I ain't got no gravity. Theoretically. If I don't have any gravity, then I don't have any weight. So I am weightless, right? But I'm still made up of atoms, right? I still have material, right? So if I have material, if there's an object, I have to have mass. So mass is independent of gravity. Does that make sense? I've tried to hit it from different sides, trying to explain the difference between mass and weight. Everybody cool with that? I know I kind of went on a tangent. Okay, so back to the question. I have units of kilograms. So, Miguel, what is a kilogram? It's a unit of weight or mass?
Mass.
There we go. And if I go from Earth to the moon, my mass does what?
Go up.
My mass. The amount of atoms I am made up of.
Decrease. Does it
It stays the
decrease?
same. It stays the same.
No.
Okay, so... Because remember, mass doesn't depend on gravity. Mass, like, I can have mass, but no gravity. So which part... I'm trying to figure out, like, where's the disconnect? Like, where are you guys... What part of this are you guys confused about?
That doesn't confuse me. The question does.
Okay. So it might just be the way that I worded it. So if... Alright, how about this? If I... What on earth is going on? There we go. Alright, so if I've got 500 grams of something and I launch that to the moon, right? And here's the Earth. So it's 500 grams when it's on Earth. How many grams would it be on the moon?
Less.
So grams is a mass. So it would also be 500 grams here. Make sense? So we have milligrams, grams, kilograms. These are all mass. So there's no change with gravity with grams, milligrams, or kilograms. If I have pounds or ounces, these are weights. And these ones do change with gravity. Does that make sense? So this is the amount of matter, right? And this is how much gravity is pulling on that matter. So if I have 500 grams on the Earth, that's telling me how much matter I have. I'm going to have 500 grams when I go to the moon. If I was 500 pounds, on the other hand, on the Earth, would it be the same on the moon? If I was 500 pounds on the Earth,
No.
it would not be the same on the moon. Because gravity is different, and gravity affects pounds and ounces. It does not have an effect on milligrams, grams, or kilograms. That make sense?
Yes.
Okay. So, in this case, because we have kilograms right here, that's in the metric system, and gravity doesn't affect the metric system like that. Okay? I mean, technically it does, but for the sake of argument, if it's kilograms, gravity doesn't change it. Okay. So we've got a few more, and I know time's getting short. So how would you describe this woman, her movement? How would you describe her How would you describe her movement? I cannot talk today. Yes, Cameron. Weight is determined by gravity. So, sorry. Go ahead, Meyer.
Would it be increasing?
Yeah. So she would be speeding up. Real quick, Cameron, when you look at astronauts in the ISS, like in the International Space Station, you would see them floating around, right? And technically, there's microgravity there, but you would consider them to be quote unquote weightless. You wouldn't call them massless. Does that make sense? So if there's very little gravity, you're essentially weightless, but you still have mass. If I have an object, I have mass. If it's made up of stuff, it's matter. And if I have matter, I have mass. Okay. All right. So I've only got a few more left. So if the object is, the object is moving to the left, and each black dot represents a 1 second time interval, how would you describe the motion of this object? Is it speeding up, slowing down, or does it have a constant velocity?
Constant velocity.
So with this, if I look at the distance from this dot to this dot, and I compare that to the distance between this dot and this dot, are they the same length?
No.
Correct. So from 0 seconds to 1 second, I travel a longer distance in that 1 second, right? And then in that second time interval, I travel less distance in the same amount of time. And in the third, I travel even less distance. So what would be happening to my velocity if I'm not going as far in the same amount of time?
Speeding up.
So I'd be slowing down.
Up.
Does that make sense? So in the previous question, notice, watch in this right here, notice the difference between the 1 second, 2 second, 3 seconds, and 4 seconds. Look at the distance between 1 and 2 and 3 and 4. You see how, as time goes on, it's more spread apart? That means she's going faster. Does that part make sense?
Yes.
So in this case, since I'm moving to the left, I'm going in this direction. This direction, sorry. I start here. My next time, I'm right here. So I'm not going as far for each second that goes by. Does that make sense? So as time goes on, I'm slowing down. Where's my mouse? Do I need to explain this again? Or does everybody get it? If you're confused, let me know. Okay. All right. So if the snapshots are taken every 2 seconds, how far did the dot travel after 2 seconds? This one's really, really easy. So how far did the dot travel after 2 seconds? Yeah, so after 2 seconds, Jamar, how far did it go? Yeah, they went 1 meter. Does that make sense? Because it's asking how far, so it's asking for a unit of length. So at 0 seconds, I've gone nowhere. After 2 seconds, I went 1 meter. Now this is one that I made myself. Actually kind of pretty proud of it. I don't know why it's lagging so much, but when you guys do it on your own, like it's much smoother. So what is the amount of distance traveled by the car? So from time 0 to time 1, I went 150 meters. Right? And then, I'm wait for it to come back. Time 0 to time 1, I went 150. Then from 150, I went back to 50. So that's a distance of 100. So 100 plus 150. So we're at 250 right now. And then from 50 meters, I went to 200. So that's another change of 150. So it would be indeed 400. Make sense? And that's with the distance. So it doesn't matter if I'm going forward or backwards. I just measure how much I'm going. Is anybody confused about that? Okay. So this one is asking for the displacement. And what's interesting about this is that I can do it 2 different ways. I can start at time 0 over here, and then displacement, if you remember from before, displacement only cares about the distance from your start to your end and giving the direction. So I ended at 200 meters, and I started at 0 meters. So just by that, we should figure out that my displacement is 200 meters. Does that make sense? So displacement, if I look at it, so my first move, I go from 0 to 150. That's my first movement. So I go from 0 to 150. And then from time 1 to time 2, I go from 150 down to 50. So this is a change of 150. If I go from 150 down to 50, I went negative 100. Does that make sense? And then I went from 50 all the way to 200. And the difference between those two is 150. You tracking, Miguel? Does that make sense? Miguel, you good? Okay. So, my first move, I traveled 150 meters. And then I traveled backwards 100 meters. And then I traveled forwards another 150 meters. So if I add all these up just like they are, and I don't change anything, 150 plus 150, I get 300. But then I subtract 100, and I get 200 meters. So that's the second way we could do it. The first way is I look at my start, which is at 0, and then I look at my end, which is at 200, and the difference between 0 and 200 is, of course, 200. So I get the same answer. Cool? All right. So on that note, that takes care of all of the ones that are different. The unit conversion ones are going to be the same as the that one assignment that I gave you, the unit conversion quiz. It's the same questions from that. Okay. So if you guys need to review information from that, let me get back to home. So any of the material that you need to review, if you go to the announcement, I've got all the information right here. This is all the stuff that you need. Okay? And the unit conversion video, this is the one that I had the slideshow and I talked about how to do the conversions. All right? So, as long as you guys go through the study guide and you understand how to do it, you should be able to do great on the assessment. Does anybody have any questions? All right. Everybody understands what's supposed to be on, like, what's expected of you and what's going to be on the quiz. All right, sorry, on the test. Cool. All right. If you have issues, reach out to me and I'll see if I can clear things up. All right. But other than that, that's all I got for you today. So thank you for your participation and your interaction. So I'll see you guys on Thursday. Cool? Yeah, this is my own personal channel. Is that what you're talking about? Like the YouTube channel? Yeah, so this is my own personal channel. Once I get a more powerful, more beefier, a stronger computer, one that's not over a decade old, I'm going to try to start making some YouTube content, because I feel like this is the way that I do things. I think is a good way to teach people about physics, and I can do some cool experiments and stuff like that. Myra, this is not going to be for a grade, the study guide. It's strictly just for y'all's benefit. Cool. Oh yes, yeah. So the assessment is part of your grade. But like I said, don't stress out about it too much. Like, if you understand the study guide, you're gonna be fine. Cool. All right. So on that note, I will see you guys on Thursday. All right. See you later.